Question number 1 is a triangle question. If cos is positive, that means it's in quadrant 1 or 4 from the cast rule, but it's not in quadrant 1, so you can draw it in quadrant 4. Draw your triangle back to the nearest x-axis so that you have a reference angle. And if cos is 3/8, that means that the adjacent side over the hypotenuse is 3 over 8, and we can label that a squared plus b squared equals c squared. So 64 minus 9, this will be square root of 55. And so now we can say that sine of theta is negative root 55 over 8, and tan of theta is negative root 55 over 3. So both sine and tan will be negative because they're in quadrant 4. And so drawing the triangle can get you those ratios, and that's why that strategy is super important, because it can get those answers easily. That doesn't mean that's the only way to solve for this. You could have gotten sine because you know that sine squared plus cos squared equals 1. And you could solve for sine that way because you know cos. And then you could use, once you get sine, you know that tan is sine over cos, and you could use that as well. But both those ways are a little bit more involved, they take a little bit more work, and I find that making the triangle really, for a lot of questions, makes it the easiest as possible. Is this point on the unit circle? If it would be, then this would be cos, because points on the unit circle are cos comma sine. So if this was the case, does it work out? Yes. Well, root 3 over 3 is tan of a certain angle. But that doesn't mean, like if we draw out our unit circle, okay, and we're looking at all the points that go along here. Root 3 over 3 is some sort of decimal. I think it's, I'm not sure exactly what decimal it is, 0.5 something or 0.6 something. But if you look on your unit circle from 0 to 1, is it possible to have root 3 over 3? It's between 0 and 1, so the answer is yes. It is possible to have that value. That value would be somewhere. These values that are listed here with cos and sine aren't necessarily ones that we have memorized. So if we were looking at this on the unit circle, if we just decided if cos of theta is root 3 over 3, is sine of theta for that same angle root 6 over 3? That's one of the questions we could ask from this. Does that make sense? Like if it's on the unit circle, that means if cos is root 3 over 3, then sine has to be root 6 over 3. This point is definitely in quadrant 1 because both values are positive. So if I drew my triangle in quadrant 1, and I labeled my angle theta, and I said if cos is root 3 over 3, what is that other side going to be? It's going to be root 6. And so the answer to this question, is it on the unit circle? The answer would be yes. If this was the same question and this was a 7 instead of a 6, you would solve it the same way and you would find out that this should be root 6, not root 7. So you would have to make a statement, sine of theta needs to be root 6 over 3 in order for that to be on the unit circle. How do you tell that you've shown the work? Or how do you tell, how did I get this root 6? Okay, so I drew this part, okay? And then if I want to find out this is root 6. I have to do a squared plus b squared equals c squared and solve for it. So that's what we did to get that root 6. Yeah, no, I didn't. I actually figured out. That's a good point. No, I didn't just like, oh, pretend the triangle all works and then say, yes, it works. No, you do have to solve for it. So this might be a question where you use another way you could check what sine squared plus cos squared equals to. If we say, well, sine is my y coordinate, that's root 6 over 3. If I square that, and cos is my x coordinate, and that's root 3 over 3, and I square that, what is that equal to? Because on the unit circle, sine squared plus cos squared is always equal to 1. So if we're checking this, we're going to get 6 over 9 plus 3 over 9 equals 9 over 9. And since that equals 1, then we know that we're right. So that's another way. Could also be 0.9 repeated. If negative 12 over 13 comma y is a point on the unit circle in quadrant 3, so what we could do is we could draw quadrant 3. We could draw an angle in standard position in quadrant 3 and label the reference angle. Now what do we know? If it's a point on the unit circle, then this is cos theta and this is sine theta. So this question is just another way of saying if cos of theta is negative 12 over 13 in quadrant 3, can you find sine of theta? Well, if I go to my triangle now and I label things, the adjacent side would be 12, the hypotenuse would be 13. Do you recognize this triangle? Yes. What's the other side? 5. And we're going to get a lot of questions that use those triangles that have nice numbers. And so what's sine of theta? Sine of theta is negative 5 over 13. Okay, this wouldn't be full marks yet because they didn't, the question itself is asking for sine of theta but not directly. It's saying find y. Right? So you need to make sure that if they're asking for y, your final answer says y equals. And in this case, y would equal negative 5 over 13. It's negative because it's in quadrant 3. Yes, you could just go to that. That would be fine. Now, one of the things that is very useful when figuring things out is to know what quadrant something's in. Because we're often going to know a reference angle and we're going to know sine, cos, and tan because we have that reference angle or because we have drawn a triangle. But we need to know what quadrant something's in order to tell if sine, cos, or tan are going to be positive. And we're going to look at ways that we can do it using our calculator. And we're going to look at ways that we would do it if we didn't have our calculator. And probably the ways without the calculator are going to be more important because they're going to come up more often on the exam. But if you had an angle of 4,300 degrees and you had to figure out what quadrant it's in, with your calculator you could divide by 360 to find out how many full times it's gone around. And your decimal place comes out to 11.94. Does it make sense that that's going to be in quadrant 4? It's done 11 full revolutions and then another 0.94 around, well, that's like 0.94 would be like going 94% around. That's almost 12 full revolutions. So if we have our calculator, we can just say this is the number of full rotations, and then our decimal place, depending on where it is going to tell us which quadrant. And you have that listed on the next page. I mean, if it's in the first 25%, it's going to be in quadrant 1, the next 25% in quadrant 2, and so on and so forth. Now, if you didn't have your calculator, I would probably start like this. Say, well, I have to take away 360 until I get to a coterminal angle that's in the first time around. So what I'm looking for is an angle that is coterminal with 4,300, but I'm looking for the first time around, because if I get an angle the first time around, it's going to be much easier for me to tell what quadrant it's in. For example, when you get 340 degrees, isn't it easy to figure out that that's in quadrant 4? So how do we do that? Well, I would start with, you could do one at a time. Subtract 360, see what you get. Subtract 360 again, see what you get. Subtract, and keep subtracting 360 one at a time until you get to an answer between 0 and 360, and then you'd be fine. I would probably start by subtracting 10 360s, because that mental math is easy to do. Does it make sense that 10 360s would be 3,600? And then what do I get? I'm left with 700. Is that still more than 360? Yes. So I would subtract one more 360 until I get down to 340 degrees. So you can add or subtract as you go along until you find something that works. In radians, we could do the same thing and take the angle that you have and divide it by 2 pi if you had your calculator. But for the most part, you will not have your calculator for these. So we're going to look at how can I tell quickly, just looking at negative 23 pi over 6, that it's going to be in quadrant 1. And the way that we're going to do that is to look at that fraction of pi, the 23 over 6, and change it to a mixed fraction. And it's all based on the idea that when you have your unit circle, and you start with 0, and this would be pi, and this would be 2 pi, what would this be over here? How many if I went 1 pi, 2 pi, this would be also 3 pi if I kept going around? And if I went twice around, does it make sense? This would also be 4 pi. And this would also be 5 pi. And this would also be 6 pi. And a pattern starts to emerge. Everything on the positive x-axis is an even number times pi. And everything on the negative x-axis is an odd number times pi. So what we're going to do when we look at our fraction, negative 23 over 6, and we change from our improper fraction to a mixed fraction. Negative 23 over 6 is the same as negative 3 and 5/6. So what does that mean? Well, the negative 3 means we would go 1 pi, 2 pi, 3 pi. That's negative 3 pi's in the negative direction. And then the second part of the fraction, all you're going to look at is this fraction more than half or less than half? Because when we're talking about going by pi, that's only half around the circle. 1 pi is only halfway around the circle. 2 pi is another half. 3 pi is another half. So if we're going 3 and 5/6, The 5/6 is going a little bit more, well, it's quite a bit more than half, so it's going to end in quadrant 1. So if we can change things first to a mixed fraction, and then, after changing them to a mixed fraction, figure out what quadrant it's going to be in, that's going to help us. So let's just do another example. We'll do 17 pi over 4 and 31 pi over 6. For 17 pi over 4, if you change 17 over 4 into a mixed fraction, can you see that you would get 4 1/4 times pi? As far as your unit circle goes, the 4 pi is going to end here because it's going to be 1, 2, 3, 4. Did I go in the wrong direction? Yes. Whoops, want to go green. 1, 2, 3, 4. And then if you have to go another quarter, will that go past the half? It'll end in quadrant 1. (31 pi over 6). Can you see that that'll be 5 1/6 pi? So if we're thinking of our unit circle, going this way, 1, 2, 3, 4, 5 would end here, and 1/6. This will end in quadrant 3.